Hello, welcome to chemistry lesson 4.07, electron configuration for the third energy level for n equals 3. So when we have that third energy level, we get d orbitals. And so now we need to talk about how do we fill those d orbitals. I'm going to have to slide my camera down a little bit because I can't see my entire diagram. Let me point out, we're not going to go above here. So it turns out the fifth period of the table and the sixth and this, we're not going to do anything with that, and we're not going to do anything with f orbitals. We got to save some of the fun for you guys for college. So let me bring this down. And I'm just going to redraw my 1s. My 1s is down here, but I don't want to cut off anymore. That says 1s underneath. What we're looking at is called an Aufbau diagram. So we talked about the Aufbau principle that says that lower energy levels fill before higher energy levels. So this is an Aufbau diagram. And it shows us fill order. And there's a reason why I had to stop with 3s. So we're going to do, let's just do a sample problem. Let's do scandium. So we watched the video of scandium. So if I look, scandium has an atomic number of 21. And since we're going to be neutral, we're going to have the same number of protons and electrons. So the 1s is lower than the 2s, is lower than the 2p, and this is what we've seen. So I put my first two electrons in 1s. Notice how I drew them. Let's talk about that now. So the split arrow, I must have bumped it. Split arrow means that one electron, so every orbital, we've said numerous times, can have 2 electrons. Every orbital can have 2 electrons. But remember those, we mentioned those numbers, the numbers from the Schrodinger equation, where you said you had 2, 1, a -1, 0, and a +1/2 or -1/2. There's a rule called the Pauli exclusion principle. Pauli exclusion principle. And this principle says that in order for 2 electrons to occupy the same orbital, they basically have to spin in opposite directions. Remember, they both have a negative charge, and like charges repel. And so in order to make it fit, it's kind of like if you and your brother or you and your sister shared a bedroom, you each need your own bed. I mean, you can share a room, but you got to have some space. Actually, what the Pauli exclusion principle says is that every electron must have a unique set of 4, those are called quantum numbers. The numbers that come from the Schrodinger equation are called quantum numbers. But what it means in reality, so the reality is they have to spin in opposite directions. And so to show that, we do one as a up half arrow and one as a bottom half arrow. All right, so let's get back to scandium. So I've got 1, 2, electron 3 and 4 are going to fill up the 3s orbital. And then I go to my 2p's. I'm going to pick a color that shows up better. I feel like this doesn't show up very well at all. I wonder if red would do better. So in the 2p's, we have to fill singly. Remember Buss rule, Hund's rule? So we've got, and then we can pair up. So far we've got 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18. So we went 1s, 2s, 2p, 3s, 3p. You would expect to go to 3D next. But then you notice this. On our diagrams, the next orbital to fill as we move up is the 4s. Well, it turns out 4s is lower in energy. 4s is lower in energy than the 3D. So it fills first. We call this a fill order. What's the word I'm looking for? Disruption, fill order. I can't think of the word. Shoot, it's just gone. I'll come back to it. All right, so where were we? We had 2, 4, 6, 8, 10, 12, 14, 16, 18. So that means that electrons 19 and 20 go into 4s. And then 21 goes into the 3D. When I write this electron configuration, I'm going to write it as 1s2, 2s2, 2p6, all my p's are filled, 2 p's, 3s2, 3p6. Now you'll see this one of two ways. So I tend to do this, 4s2, 3d1. I like to write it just like the way my diagram shows. The book will go 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. So the question is, do you keep all the threes together? It's probably better to do this. Whoops, and I made a mistake. That should be 3d1. No, I didn't. Okay. It's probably better to do this. In fact, I should probably just make the switch. Why? Because if I asked you for the valence electrons, how many valence electrons does scandium have? Oh, I did make a mistake. No, I didn't. Okay, I've been recording videos too long. This is my tip that it's time to stop. So if I ask you for the valence electrons, remember the valence electrons are the highest N value, and my highest N value here is 4. So actually, I have 2 valence electrons. These Ds don't count. They're considered inner shell. Fill order exception. That's the word I was looking for. Yeah, I'm also forgetting words. Now we have some elements that violate fill order. So elements like chromium and copper, they violate Hund's rule, and I usually stay away from those. I let you save those for college too. All right, I'm going to pause the video. We're going to try a few more sample problems. I'm going to switch out to the practice sheet in your packet. All right, so here we have an Aufbau diagram that has all 51 orbitals. So if we go up to the 7th row of the periodic table, we can see that these are all the orbitals that we have. My 5Fs are cut off a little bit there. And again, we're going to stop here. So this is our line. Shh. I won't ask you to go above. All right, so what I would like you to do is I would like you to take a crack at doing, let's start off with an easier one. Calcium. So we're going to do calcium over here. And let's do, let's get a little fancier. Let's do bromine over here. Okay, pause the video and try this and see how you do. All right, here we go. Calcium has 20 protons, so we're talking about 20 electrons. And I'm going to start filling this from the bottom up. So I go 2, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is my Aufbau. My electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Bromine, on the other hand, has, where's my number? Ooh, 35. 35 electrons. All right, starting at the bottom. 2, 4, singles, 5, 6, 7, pair them up, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I go from the 4s, I go to the 3d. So I go 20, 21, 22, 23, 24, 25. These all fill singly. 26, 27, 28, 29, 30. Then we go to the 4p, 31, 32, 33, 34, 35. So bromine is 1s2, 2s2, 2p6, 3s2, 3p6. We do want to keep our threes together. So we're going to go 3d10, 4s2, 4p, 2, 3, 4, 5. So this is long. And what we're going to find out is there's actually a way to shorten the shortcut. We're going to shortcut the shortcut. So this is supposed to be a shortcut. And we're going to give you a time saver on that. How many valence electrons? And how many inner shell? For both of these. Did you say 2 valence? You'd be right. So inner shell, we've got 6, 7, 8, 9, 10, 16, 17, 18. Or I could have just subtracted 2 from 20. That would have been faster. How many valence over here? I've got 7. So that means I'm going to have inner shell. What is that, 28? 35 minus 7. Is that right? 28. Yeah. Okay, those are electron configuration and Aufbau for main energy level 3 and up. You can go ahead and start on the homework problems and email with questions. Thanks for watching.